recording this to the cloud. I've got my pink suit on in honor of a very special program. In fact, I have a pink hat I can wear too. I got this in Vietnam about a decade ago, actually. And people said, why do you want a pink suit? And I actually got a light pink suit with pink pants, so they can call me the Pink Pantser. And then a purple one. And they looked at me and she says, why does you want a pink suit? And I said to her, my sister said I look good in pink. And I tried it on. She said, you do look in pink. So, I'll make you two pink suits. And so I have two pink suits and a purple one. Um, I don't know why I put this on today. Actually, we have a potential dean interview in town today, and I thought I'd wear it to the dean's interview, and I never made it there. I was too hyped about this week on computational thinking. I started reading the articles and so forth. So week 8 on computational thinking, who better than to get but Tom Ball from Microsoft come join us and talk about microcode. Tom is at Microsoft Research, a leading researcher for Microcode, and I've sent you his bio. I've sent you a ton of articles that he's working on. You maybe had a chance to print one or two of them out. He works in the area of programming languages and software engineering in Redmond. He's a member of the RISE group. He can tell us what the RISE group stands for. For the past 5 or so years, he's turned his attention to the problems plaguing professional software development and focusing on the area of simplification of code, which has become a huge theme in the mobile app world today. He's led a team at Microsoft that helped deliver the BBC microbit to over 800,000 Year 7 students in the UK alone. I'm assuming that is being used besides the UK and other countries. But Tom will get to that, and he'll talk about that. He'll educate us today. Then he started working on Microsoft Microcode, a web-based platform to support education. Working with the Microbit Education Foundation, over 6 million microbits have been distributed worldwide. It's probably a lot higher than that. This is probably written some time ago. I'm not positive. Tom can update us on his whole bio. Recently, he's been working on a project called JackDack, a new platform for creating electronic devices. He's got several articles listed in his bio, including how families design and program games, a qualitative analysis of a 4-week online in-home study, web-based programming for low-cost gaming handhelds, physical computing, a key element of modern computer science education, and on and on and on. He probably has a number of highlights that he would like me to talk about, but I'll let him fill in the gap here a little bit. Rojan is joining us from Amazon, and she helped create the connection for this one. We've been friends for a few years now, and we're just getting updated, and I found out about microcode. It just happens that this is the week we talk about computational thinking, CP. And if any of you were in the interviews of the new faculty member we're hiring, you know all 3 interviewees focused on computational thinking. Their research was on CT. In fact, Jill, I don't know if Jill's here yet or not, but yeah, Jill's here. She says, why is everyone focused on computational thinking? Why do you want to focus on this? And I said, I don't know. It just seems to be the thing to do this year. This is the in thing. So we're going to get the in thing this year from Tom. Tom, would you like to first of all fill in the little gaps in your bio, update us in what was missing in that, the data that I mentioned, and so forth,
thanks.
and then we can go into microcode and whatnot.
Yeah, Kurt, thank you so much, and thanks to Regine for setting this up. We also have a member of our Make Code product team here. It's Richard, who I see. Yeah, so about 8 years ago, we were working on something called Touch Develop. It was that was back when Microsoft had a phone, and the idea was, wouldn't it be cool if you could program your phone using your phone? So instead of having a big desktop, like just have a programming environment that was touch-based. And so, a long story short, that got us into a proposal that the BBC had to have programming for the microbit.
Wow.
And for the microbit, which is this cool little board I'll tell you about. And we had already done a lot of work on compiling. We are compiler people in the research and software engineering group, so we knew a lot about how to compile for different types of architecture. So we said, oh, we'll do the website and the programming environment based on this thing called Touch Develop. And anyway, that went quite well in the UK in 2015, 2016. And we made a pitch to our professional developer tools team called Developer Division, and started up something called Microcode. And I'll tell you about that as well. So this whole story is really about a journey that started really almost 10 years ago, actually 2011, when we started with this idea of simplifying programming for people on smartphones. And through various incarnations, we've reached a different point, which I'll tell you about today. So that's.
Would Richard like to introduce himself?
Sure, Richard, why don't you go ahead?
Sure. Hi, I'm Richard Knoll. As Tom said, I'm an engineer on the Microcode team, and I've done a lot of work with the microbit and arcade computing environments that we have.
Yeah, so if you have questions, put them in the chat. Richard or Rogine may be able to answer. If they're not, if you have a moderator, just call out and I'll respond. So I'm not going to talk.
Tom, I think one more of your members have joined us or is in the process of joining us.
Oh.
Not positive.
Okay.
If that is Jonathan, is he part of your group?
Jonathan who?
Yes,
that's Pelly. That's Pelly.
Okay.
Yes, Pelly is one of the key architects behind Microcode, many of the things we've done. So that's Pelly back from vacation in Mexico.
Hello.
Hey,
welcome.
Welcome back. Okay. Yeah, I'll do call outs to the people who are on the call who've contributed. There are many more. So I wanted to tell you about Microcode, and it's 3 P's to remember: the portable, programming, and physical computing. So you heard about computational thinking. I'm curious about how many people know what physical computing is about and what the BBC microbit is about. So I have a little bit of an overview of the 2 technologies. If you haven't heard about them before, and I'm going too fast, just please poke in, tell me to slow down. But I do want to get to sort of microcode. So I'm going to start with this idea of physical computing, talk about Arduino and sort of what the BBC microbit did in this space. Then I'm going to tell you about Microcode, the platform that Pelly and Richard are key developers behind, along with others. And then I'm going to tell you, really what we've done with Microcode, bringing portability into physical computing and programming. So 3 P's to remember. So physical computing, the way it's often defined is a software and hardware system that senses and responds to the real world. Well, isn't your PC like a physical computer? Yeah, it has a keyboard, it has a screen, but often we think more of things that have sensors, maybe an accelerometer, and maybe are smaller than a PC, but they're small systems, and we know them in computer science by sort of a different name. Reactive systems are embedded systems. So if we think of a thermometer or a heat sensor, humidity controller, temperature controller, it's sensing the temperature in your room, and then it's activating, some heater based on the setting that you want. That's a type of physical computer. But in particular, physical computing has been used more in the education context, because I think reactive systems comes with sort of a formal methods sort of baggage, if you will. Physical computing is really focused more on, I would say, classically CS education, but CS education that's hands-on with low-level hardware. And so in 2005, you had this Arduino project, which has gone worldwide and is probably known to many of you, which is a very low-cost hardware prototyping platform that comes with a small board which can be powered by battery, and it has many opportunities to wire sensors to it, as shown sort of on the left, with classic sort of breadboarding techniques. We also have Raspberry Pi, which is also used by a lot of people creating bespoke devices. The Raspberry Pi, though, has a lot more memory than our classic Arduino. It runs an operating system, whereas the basic Arduino 101 sort of very, very small amount of memory, maybe maybe even less than 16K. I don't recall on the Atmega, the original Atmega. But despite this, limitations, there's been a lot of work using these sort of low-level devices for physical computing, for showing people how to create physical devices that sense things and react to the sensor. So control motors, control actuators, as well as doing sensing. Make magazine. So a lot of the making with digital means using Arduino or Raspberry Pi. So in 2016, the BBC, which has a long history with computing going back to the 80s, they had an Apple II computer called the BBC Micro. In the 2000s, they wanted to have a new type of a computing experience that was focused on CS education, and they wanted to think of something that was appealing to teachers, but maybe without all the wiring of Arduino. So they came up with this thing called the BBC Microbit, which you see here. And it has, built into it a whole bunch of goodies. So it has a tiny little screen that you can scroll text and numbers on, 5x5 LEDs. LEDs also can be light sensors, so that array also can do basic light sensing. It has 2 buttons, so it has a keyboard with A and B buttons. It has a bunch of pins at the bottom that you can attach crocodile clips to, or you can slot it into a holder. And there are various low-level protocols that are spoken by the chipset on the back. On the back, there's a whole bunch of other features, including the programmable microcontroller, which has a full 16 kilobytes of RAM. That's a third of what my Apple II computer had. I had 48K. It has 16K of RAM. Of course, it has a much more generous storage in flash, 256K. In addition to that, it can be battery powered. It's very low power, so it can run for weeks in certain modes just off of a AA battery. It has a USB interface for file copying, so you can essentially program the thing through just a file copy. It's got an accelerometer, a magnetometer, a compass, a temperature sensor, as well as in the upper left, and this is really a killer feature, an antenna for doing Bluetooth. So one of the things the Microbit did really well was to package all these goodies up, in one board that had no extra wires. So just out of the box, you could plug this in, and many, many cool projects. So on the left here is a step tracker, which was programmed by the student, and you can count steps. So a fitness tracker. On the right-hand side, very popular rock, paper, scissors game, which I'll show you a version of with Microcode. Here's something Pelly created, which was a light sensing robot. So here you have sensing and actuation together. So when the light strip goes on, the lights are detected and the robots open their mouths. This is a really cool little thing. And here you can see sort of the Microbit being personalized by students, put into an art project that's now interactive. So, this idea really gets students excited, not just doing the programming, but really sort of doing the making first, and then the coding is after. And that's where we get to this idea of make code, which I'll talk about in a second. Many other great activities. This is from 2019. There's many, many other projects. There's a whole host of partners who've created projects with the Microbit, with our programming environments, done everything from wearables to environmental sensing. I think they sent a Microbit into outer space at some point. I hear there might be one going to the moon, but like going to the moon these days is sort of passé, right? At least they're trying to make it passé. Here's the Microbit with the radio. So there are 2 Microbits, one in the cardboard car, and the other Microbit in the person's hand is sending signals based on the orientation of the Microbit, which is detected by the accelerometer. So here's like a super cheap radio-controlled programmable car using the Microbit. Okay. So any questions so far? Physical computing, Arduino to the Microbit.
Risa has a question for you, or
Yeah,
two.
please.
Risa.
Hello, thank you very much. I'm really enjoying, since I like both computational thinking, and also I have worked with Microbit, BBC Microbit. I wonder, how is the speed of sample rating of the top 2 rows of LEDs, the matrix of LEDs that they act at the same time as light sensor?
Oh yeah, this is really interesting. So there's an underlying operating system, if you will, a hardware operating system called Codal that is written by Joe Finney and others at Lancaster University. And basically there's these low level timers. So first off, the first thing to know is that the way the LEDs are wired, you can only turn on one row of LEDs or one column at a time. So just like old televisions, it's going through a scan loop. So if you take a picture of a microbit showing a heart or something, you'll only ever usually see one or two rows on at the same time. Actually, it's not rows, but so the first thing to know is it's scanning. And so it just interleaves. It interleaves displaying and detection. So it's so fast that you really can't see it. And LEDs are really not built for being very good light detectors, but you can actually detect incoming light from the environment at the same time, in quotes, that you're seeing an image, because the LEDs just turn off and on fairly fast. So you don't get a feedback loop from the LED lighting itself up. More details are in the code, and I'm happy to point you to that. I am not the one who wrote the code. Yep. So
Lisa,
you can
you have
actually
anything else?
Yeah.
Hey, Tom,
No.
can I ask you a quick question here?
Yeah.
So I used to actually work for a company, and I did curriculum development for microbits.
Oh yeah.
One of the things when Dr. Bonk had mentioned that you were going to be coming last week, and he'd referenced microcode. I hadn't heard of microcode because we'd always used Makecode.
Yeah. So you're right. Microcode is something new that I'm going to get to. I'm going to get to Makecode next.
Okay, gotcha. Cool.
Yeah. Okay. And
Tom,
microcode.
I have a question too.
I would just say, just a second, that microcode is a very well known in computer architecture circles. So I'm using an existing term, but that term is really not known by people in CS education, at least people doing CS education in schools. I don't know that they know what microcode is unless they've got a CS degree, right? So I'm sort of reusing that idea.
Oh, thanks, Jonathan, for the link to Lancaster. That's useful for us.
Yeah,
Tom, my question is more historical in nature. This course has its roots 30 years ago when I developed it over that. And back in the day, MIT Media Lab was the big place for physical computing with
Yes.
the Lego
Sure.
logo and Logo robotics and that kind of thing. Would you say that would you agree with me that that's where a lot of the roots come from for this area today?
Well, we'll get to that. I mean, we use Blockly, which is based on Scratch. There's
Right.
there's a lot of historical precedent and obviously constructivism
Right.
and Mitch Resnick's work, and all the work at MIT. I think one of the things we're doing here, which I think is different, maybe. At least in the modern days, is putting together the web and the physical computing in a new way. I'll get to that when we talk about Makecode, but certainly there's a lot of shared ideas, sort of from the learning theory side, which I'm not an expert in, but and also in terms of Blockly. So Blockly is this way that a lot of people are first introduced to coding, and so we draw on that, as well as something called Coded Game Lab that I'll talk about. But yes, I mean, I don't have I don't have a related work section in this talk, but there's volumes.
Volumes, yeah. So
there's
for
volumes.
I'll briefly, for my students' purpose here, constructivism. There was a strand called constructionism for the making side. So constructionism is building things, and that comes from Seymour Papert and other people's work at MIT. So if you read it, if you're looking for learning theory backing up what we're talking about today, that's where I would start with. And the Scratch software language for kids, I had a student want to do a dissertation on it during COVID, and she couldn't because of COVID, and she ended up doing a bit emojis instead. But yeah.
There's many ideas. I mean, we had a guy at Microsoft Research, Andy Bagel, who did one of the very early predecessors of Scratch, and there's a whole history about the block-based programming language that I could talk at length about. We could go back to syntax-directed editing, which is a precursor of that. We made use of that in Touch Develop. So how do you let people program without syntax errors, because that really, anything that gets in the way of exploration, that's just sort of, you know, accidental complexity, you sort of try to get rid of. And constructivism really, you know, the idea is that, you know, a lot of learning goes on through exploration. And so again, like make code, we think of making first, like what do you want to make? Coding is in service to the thing you want to make. It's not the end in itself, although these days we have things like learn to code and, you know, so yeah, we could talk a lot more about the theory behind this, which I'm not an expert in, but yeah, a tremendous amount underpins what we're talking about.
Yeah.
A quick,
So what, we'll go, the
maybe
one,
can I leave in terms of the microbit, because it's it was driven by the BBC, and for the history, the BBC Micro is
Yes,
of hardware. Yeah.
Yeah,
And
so
that's also why they went
yes.
into hardware.
Yeah, the BBC, for those who don't know, is part of the UK sort of it's funded by the government, and it's part of the Royal Charter. And in the 80s, they did the BBC Micro, which was a PC, and the BBC did the educational content to explain to the public what is a personal computer, because in the early 80s, nobody really understood a computer, much less, you know, in the public, much less why they should get one themselves. So the
before
BBC
you move on,
was,
Leo
I
has
think-
the last question before we move on. Leo.
Hello, Tom. It's really nice to learn about this circuit board, you know, and obviously it offers a lot of differential features in comparison to other circuit boards. I would like to know more from the perspective from equity. How affordable are these new circuit boards?
Yeah, that's a very good question. And here I think maybe I'll go into, you know, this slide here, because it does talk about some of the goals. And when the BBC started this, it was really that, you know, this should be affordable, that this board should be affordable to many. And so the cost is under $20 for the basic board, for the kit, which includes the battery pack and a cable. I think it's just under 20. So the goal is to keep it low cost, and certainly the BBC helped subsidize the initial. Well, the BBC's partners, I should say, banks and such, helped subsidize that. Microsoft, we did touch develop. All the partners did the work for the BBC microbit at no cost to the BBC or to the public. And we continue with the BBC Microbit Educational Foundation, the Microbit Educational Foundation. It's a not-for-profit to really try to keep things as low cost as possible. So the Education Foundation got started at the end of 2016 to take the microbit worldwide with these 3 core goals: simple and easy to use, effective for teaching digital skills and creativity, bringing inspiration to a diverse range of people. Part of that is to make it affordable and to make it widely accessible. To date, we have, and I'm going to talk about accessibility and affordability in the microcode section as well. So it's a great question. To date, we actually have over 9 million microbits distributed in over 60 countries. At the same time, in 2016, Peli Dehulu and Michal Moskal and I had this idea, and we demoed it to people in Microsoft, that we could move away from touch develop. We could embrace Blockly and something called TypeScript, and do a website that would allow you to do programming of different types of physical computers. So this is an old snapshot of the Makecode.com website, which are web-based editors for programming this low-level hardware. So, you know, you need a web browser, a modern web browser, but you're going to program this thing with 16K of RAM. So the idea of Makecode was, we want to simplify making, and in particular coding with physical computers. We want to just meet educators where they are. This is not a Windows-specific technology. It's open source, it's cross-platform. It works in any modern web browser, almost any operating system. Chromebooks, iOS, Android, macOS, Linux, Windows. We did a lot of work to actually to bring Makecode as a web app to as many platforms as possible. And then, you know, we looked at Scratch and we thought, well, Blockly is really good, but but Microsoft's always been about educating people to also, transition if they want to modern programming languages. So we have support for progression from blocks into JavaScript as well as Python. So we wanted to also support this idea of progression, which is quite unique. So the other aspect of Makecode was we really wanted to work with partners to make their hardware light up in the website. So we started with microbit.org. If you go to makecode.microbit.org, that's actually the Makecode editor, and that includes at the top Blockly and JavaScript editors that all compile down, because we're compiler people here, to both a JavaScript that runs in the browser against a simulator, and also we compile in the web browser all the way to machine code. So you actually get a binary executable that you can then download from the web app and then copy it over the USB connection to your device. And so in our first year, we brought on several partners. We brought on Adafruit as well with the round board. We call Microbit the square board, the rectangular board. And then we created our own editor for retro games, and I'll come back to that. So this is actually from last week. I just went to Twitter, which I don't go to very often these days anymore. Put that aside. And I just searched for Microbit, and I looked for Makecode. Makecode is like the #1 editor, and I just looked for where are people using Makecode. So here we go, and we see students in the classroom, a teacher up at the website. Here's somebody with actually programming a drone using Makecode and blocks. Here's some of these block programs can get pretty large. Here's somebody else doing a reaction game, a very simple game. You can see the microbit attached via USB with the web app and the simulator running. Here's some students using a touchpad, and I think this might be even using the Bluetooth connection to download the code over Bluetooth, which we support as well on Android and iOS. Here's some other students working together in pairs. Again, you can see the microbits attached. There are some other students similar, and here's like, wow, here's like a beautiful big touch screen, in a classroom with lots of compute availability. So you sort of see the idea here, maybe I'm getting at, is like, yeah, we were fairly successful in sort of bringing the world of the web and physical computing together. I think if you look at many CS classrooms now, they know about Makecode, they know about Microbit, but you see there's a cost associated with doing this, right? You basically need a computer that can run a modern web browser. You need to have an internet connection generally, although we have some apps that can run via USB install. So that brings us to so any questions? I should stop there. So that's sort of a very quick tour of the hardware and then our programming environment. There are many papers we wrote about Makecode. There's many stories to tell about Makecode. But if you go to microbit.org, you'll see there's several editors, and Microsoft continues to actually do a huge amount of work. In fact, Richard has just finished up porting Makecode onto the brand new Blockly, which is a complete rewrite of the system. So we do a huge amount of work for essentially for the Microbit Educational Foundation in support of bringing the excitement of physical computing to more classrooms around the world.
So before we ask if anyone else has a question, do any of the other two Microsoft people want to add a comment? Richard? Kelly?
No, not particularly. Just that I guess one thing I would like to mention is that there's a lot of exciting work being done in accessibility in blocks right now, both on the research side and on the practical side. So a lot of the reason we went through this big Blockly upgrade is so that we can kind of be on the forefront of that whole effort. So
Good
yeah,
point, Richard.
that we're putting a lot of work into right now.
Yeah, Blockly is inherently very visual, and now they've had an experiment for a while, but they're forefronting that cursor-based editing with keyboard.
And the other person from Microsoft, you
Kelly.
said Kelly?
Kelly, you want to add anything? There's a lot of history.
I think maybe we should gear up to microcode because we could talk for microbit for days.
Yeah, we could talk about these two for a while, and we're already at and I'm
Yeah.
assuming we have a full hour, Kurt?
Yeah, sure. Yeah.
Okay.
If we go a few minutes over, that's okay.
Okay.
Yeah.
Yeah, we've got a half hour, so it's good. Thanks, Pelly.
Feel free to dump questions in the chat, and
Yeah.
we're
If
happy
you
to
have questions, we have two people who really know Makecode and Microcode and the BBC Microbit and everything. So feel free to ask technical questions, and I'll leave it up to those guys to help answer. So the idea we had several years ago now, well, actually just 2 years ago or so, was, wow, okay, we've had all the success with the BBC Microbit, but what if you don't have a school with a computer lab? Like, what if you don't have, PCs? What if you're remote? What if you wanted to take the microbit out into a rural community, that doesn't have reliable internet, or maybe this power is spotty? And then the other thing we were also thinking about was well, why can't we even go earlier ages? So we were inspired also by Kodu, this programming environment for games that was done by Microsoft Research, which has an even simpler sort of block-based paradigm that is now known by horizontal mode. But Kodu essentially sort of really pioneered this and brought it down to like even second or third grade. Whereas the microbit generally has targeted, sixth grade and up, I would say, maybe fifth grade. But could you bring it earlier? And so, what would our assumptions be like for such an environment? Right now, basically, as you'll see, good eye-hand coordination. So it is still a physical device. You can't talk to it yet. Some basic arithmetic knowledge, sort of adding numbers on your fingers, maybe counting up to 10 on your fingers, and non-assumptions like, your reading skills, maybe you're a reader, maybe not, but we don't want to assume anything about reading. So one question is, what age could we go down to? Still to be determined. So what made Microcode possible was in 2020, the BBC, the Microbit Education Foundation said, hey, we need a refresh. The timing was not great because supply chain disruption meant it took a little while to get this out, but it was a new version of the Microbit that came with some new features, a touch logo on the front, a microphone, and a small speaker. But importantly for us, if you see in the lower left, we got a significant upgrade in RAM from 16K of RAM to 128. And so that's enough to drive us to have a frame buffer for a small screen. And we also upgraded to a Cortex M4, much faster, so able to do many more things simultaneously, like drive a small display, and also a doubling of flash. So we can put more code in there and maybe more assets, like, for example, images. So you can learn more about the V2. It's been out a significant number. I mean, V2 is what's selling now. I think the V1, I don't think they produce them anymore. Okay. So the other thing that happened was we had this thing called Makecode Arcade, which was our editor for programming retro games. And we had a hardware design that basically said, hey, if you want your game, if you want your hardware to work with Makecode Arcade, it needs to have a certain display type. It needs to be able to drive that display. And of course, the microbit by itself is not an arcade capable computer. So we actually did a design of a shield that you plug the microbit into, as you see here, and the microbit, now you download your Makecode Arcade game onto it. So you create the game in the web browser, just like with the microbit, you download it to the microbit, you plug it into the shield, and now you're playing the game you created and taking it on the go with you. So we actually have three separate companies with 3 different shields that have this capability. And so, this took more work on our side, but it gave the microbit, it's sort of a new life. Like, you could use your microbit V2 now for all the physical computing things, but you could also use it to go to Makecode Arcade with this additional shield. And the shields vary in price from, I think, $25 on the left to $60 on the right. $60 on the right has a beautiful 3D printed case, a true D-pad, a LiPo built in, and a larger screen. So this is what led us realize microcode. So what is microcode? It's a programming environment for the microbit v2 that fits on the microbit v2. So as compiler people, you know, we were like, we packed everything into a web app, an editor, a compiler, a simulator. Let's pack everything that somebody needs to do some microbit programming onto the microbit itself. So this was quite a fun little experiment to get started with. So what is microcode in terms of implementation? It's the combined system of the microbit with this MakeCode arcade app called Microcode plugged into this arcade shield. Okay, and it's all open source too. So now I'm going to go to Pele in video to just show you the interaction for creating a small program. And I think maybe I'll just talk over this. I don't know I don't know if by default you can hear what he's saying. We'll see.
When you share your screen, you have to hit optimize sound and optimize video. So if you want to unshare.
Okay, no, I'm just gonna talk over it.
Okay.
Sure. So basically you see here the KittenBot shield. Pele's holding it and he's creating with the beta version. This is well over a year old, microcode. He's using the buttons on the left to essentially navigate and select items in this horizontal mode. And what he's doing here is just, you know, creating a little dot on the display whenever we shake the microbit. Also, whenever we shake the microbit, we're going to send a radio message to another microbit. So this is using the radio, underlying radio capability. And also we're going to, when we receive a message, we're going to show a duck. So it's 3 simple rules. Let me just stop it there just so you can see. Again. Oops. What happened? There it is. I think I just need to. There it is. The 3 rules. So the first rule says, whenever anybody shakes the microbit, show a dot on the screen. Also, whenever anybody in parallel shakes the microbit, send a radio message out to any microbit listening. And then finally, show a duck whenever you receive a radio message. So this is a very cool little radio program where you have 2 microbits programmed with the same program. And when you shake, you send the duck to your partner. Oh, here we're also going to have a 4th rule. So there's Pele, he's shaking it, and the other microbit gets the duck. Okay, let me show you that again. It happened very quickly. So he shakes it, and the other microbit gets the duck. He shakes the other microbit running the same program. Okay, so that's the video. Let me show you in more slow-mo the same user interface, but here we have it as a web app. So we basically have these when-do rules in microcode. So when some event happens, do something. So if you're familiar with like the idea of guarded commands, this is like guarded command. So you have a guard, a condition, some event, and then some action. And so we're going to say this is like our hello world program for the microbit. It's called happy sad. So when button A is pressed, so press button A, you see we have this tooltip, which we can turn on and off, and they're localized into different languages. We're going to show an image, and that image is going to be the default happy face. And then we can also, when button B is pressed, we're going to show that we're sad. You know, in this case, we can go and, oops, maybe the same. Sometimes I turn the thing into a Cyclops, and we can do that too. We can make it sad. So here's like the simplest sort of our hello world program. Now with the web app, I'm not, it's hard for me to demo with, you know, with the shield to you. So what I've got here with the web app, we also have the ability to download the program onto the microbit and see it live. So I don't know how well you're going to be able to see this, but basically I'm connecting my web app to let's see, connect, and it's not working. Do I have the right one? Let me see.
Tom, I shifted the view so everybody could focus in on you and the
Thank you so much.
you're sharing as well.
That.
Yeah.
Okay, let me see if that. I have several microbits here and I sort of forgot which one I've got. I've also got blur on, which I think is not friendly with, the camera. Let me just see. I am not getting any connection. Nah, no compatible devices. Okay, we're gonna skip that part. Believe me, it works. You can try that. If you have a microbit V2, but you don't have a shield, you can you can download a hex file to your microbit to make it microcode compatible. Okay, so we've actually had hardware manufacturers creating these shields. And also we have this JackDAC system, which is this plug and play for microcontrollers. So what you see here is one of our partners displaying microcode running on their shield, but there are also these modules around it. These modules are connectable to the shield, and actually microcode recognizes them. This project's called JackDAC. Maybe, Peli, you could put in the AKA on that. So there's a separate project for extending the reach of a microcontroller using principles similar to USB, but at much lower cost. So say you have a game, but you want more buttons, right? Well, how are you going to do that? Or, are you going to, or you just need more buttons to work with than the microbit has available? So our hardware partner KittenBot in China has run several workshops now. Here you see actually the localization that's taken place. So we have the microcode app localized into about 20 languages through crowdsourcing and Crowdin. Peli drove that work, and that means that we have the hex file for several, for 20 different countries for just the tooltips. So there's only like, I think 100 words we need to translate. And as you see, like, one of the cool things is, like, you can get quite a few of them here. Like, each one of these would be like, let's see, $15 for the microbit plus another $25 for the shield. So each one of those is like $40 investment, not counting JackDAC. That's separate. So here are some of the kids working with microbit, with microcode in the microbit in the workshop. The other thing that Peli and I have been doing is we've been teaching with microcode in various classrooms. And so I created essentially this box that has about, I don't remember how many, 16 or so shields. So this is the higher end. This is about, I would say, $600 worth of tech. But I can just walk into a classroom that has no internet, no computers, and get the kids programming in like 5 minutes. Right. So the idea here is like, well, what if you had like 4 of these or 6 of these or 8 of these in your backpack, waterproof, with a solar charger? What could you do? Like, where could you take it? Where could you go? So this is the key idea. So here's some of my tech all lit up, showing you different programs. So I think one of the key ideas about microcode, we have these goals. But I think one of the ways we sort of achieve this lower cost programming solution is by embracing low cost hardware, and really the key idea here is portability. Like, what if you could take the microbit and a programming environment anywhere you want to do creative things? So you want to go out in nature and measure the temperature. Why shouldn't you be able to just program there? Why do you have to worry about bringing a laptop along? Why do you have to worry about whether you have an internet connection? Now, you do have to worry about power. That's always something. But I think one of the ideas of portability is you can do the programming in the context where you're working with the physical computing device. And also, as we found out, these shields and microbits can sort of be freely shared. Hey, I created a program on my microbit. Hey, you want to try it out? Put it in, if you want to edit it, here's the microbit, put it in your shield, edit it. So now the microbits become not only the programming environment, we store the user programs on them, and we store up to 3 programs. So we store in Flash the children's programs, so they can be shared around. The other thing we've done some evaluation on, no evaluation. We've done some creation. Is like, well, what if you come into an environment where you got 10 kids and like 2 shields, or 4 microbits and 4 shields? Like, what can you do to help? And maybe the kids have never seen a computer before. So how are you going to help a teacher or the kids learn about a programming model or the notion of events and how those events are tied to pieces of hardware. So what you see here is, I got myself a laminator, I got PowerPoint and created a bunch of laminated cards that describe visually sort of each of the events. And you can see here like the A button, which has the silk screen on the microbit, is paralleled with this icon. So, the idea here is like, if we're really trying to take this places where maybe, you don't have good access to internet or resources, can you supplement the microbit and the microcode with materials for talking about programming concepts, assuming again some teacher PD, some teacher training, which is still to be determined. So here you can see sort of some of the designs of these cards, which attempt to link the visual icon used in the programming model to the different parts of the microbit, like the microphone icon. Is that universal? I don't even know. I think not, probably. But here the attempt is to show the relationship between the programming elements and the pieces of hardware. The other thing that Pelle really pioneered and worked on with me is to bring robot programming to Microcode, and this is what he has been doing with his class. So one of the things that's really cool about the microbit, all these micro words, is this edge connector at the bottom, which allows you to plug it into other devices. And one of the classes of devices that, thanks to Papert and Mindstorms and Resnick and the MIT lab, people are crazy about robots. Like, what do you do with the microbit after you did the happy sad program and all the other cool exercises? Well, if you really want to do some physical computing, one of the things the microbit doesn't do well is move around on its own. But if you plug it into a robot car, oh my gosh. So these robot cars are super plentiful. There's like maybe at least 20 different ones that are available for the microbit, but they all come with like different programming libraries. And so Pelle and I sort of said, hey, here's an opportunity. Let's see if we can do simple line following programs using microcode. So now if you actually go to the web app, and if we have time, I can show you, we've designed a set of tiles that allow you to program the robot. Here, I'll show you. So here, instead of happy, sad, we have go stop. So here we have the first line of this program essentially sets up a radio group saying, hey, I'm going to communicate the commands to a robot car on radio group 1. This is an opportunity if you have 10 robots in the class with 10 radio groups to talk about network security. We have none. So we basically tell each student, like, look at the number of your robot and set the group number. The second line essentially tells the robot, move forward and turn on your blue light. And the second, and that's a command that the robot just starts moving and it's not going to stop. So if you only had a program with these first 2 lines, you could make a robot that would just go and hit the wall. So you better tell the robot car to stop. And that's what you do with the B event. With a B button. So press the B button, press the A button, go, press the B button, stop. We also get sensor readings from the sonar, the distance detectors, and those get fed back over the radio protocol to microcode. And so here, we basically tell it, hey, if you're approaching something, turn around. So what's going on here is, if I go back, is the user program, the student's program is running on the left-hand side. It's sending commands to the robot that's listening for commands on the group channel. And the robot itself is detecting events and sending them back. So we have new classes of commands for the robot, as well as new events. So that's been, I think, fairly successful as well. So experience to date, we have hardware partners running workshops. We have colleagues in Lancaster University who've conducted microcode trials in schools, evaluating basic student engagement with microcode. That's under submission. Pelle and I have been teaching microcode in Seattle. And the other thing we've done is we've reviewed the starter projects for the microbit that are done with Microcode on the Microbit Educational Foundation website. And what's nice is that our programming model, very simple programming model, microcode, lets us do, a substantial, like 3/4 of the beginner projects, a little less than half of the intermediate projects, and about 1/3 of the advanced projects. So even with a very simplified programming model, there's a lot that can still be done with microcode. So really what I've shown you today is like physical computing, I think, is here to stay. It's a basis for engaging with hands-on computing, where you learn about the hardware, you learn about reactive systems that sense and react, and you program that reaction. But I think what's new here with microcode is making this portable, like taking the microbit plus the shield and going to anywhere you can think of, and how would you make use of this? Furthermore, not only you're limited to microcode, you could think about other sort of apps. So in terms of future work, this is my last slide. We have a number of questions. One is, how young can we go with microcode? We really don't know yet. Accessibility, we found some kids really gravitate to the game controller, but that does require manual dexterity. It's still a very visual programming environment. We do have the ability for kids who aren't maybe super readers yet to actually just play and explore and sort of learn the words for the different through the tooltips. Certainly there are challenges with the microbit for making it more accessible. But in terms of a programming environment that's a handheld, that's a whole nother thing. We are working with some nonprofits to look at trialing microcode in remote and rural communities. And then the other thing we're thinking about is, well, what other sort of applications could you put onto the microbit with this shield and the ability to have this color display with the D-pad and the extra buttons. So we're working with Lancaster University on what we call microdata, which is doing simple data science experiments with the microbit. So setting up to measure things that the microbit can sense, like the temperature, recording that, visualizing it, maybe a new type of calculator or other things. So we're also creating some new platform to make it easier for people, to researchers or anybody who knows how to program with Microcode already, to actually create their own microstar, we'll call them microstar applications. So that's what I've got, and I see there's a lot of chat going on, and take questions.
If anyone didn't get their questions answered in the chat, or if you want elaboration on those questions, or if you just want to get Tom's perspective, go ahead and jump in. And Tom, if you could take off the sharing, we can have everyone on screen here. We can go back to your slides if we need to. We've got Amelia from Japan here. I'm sure if she's up, early in the morning in Japan, taking all this time, maybe she's got the first question. We got to allow her a chance to chat. We have a couple of my visiting scholars who are in Indiana. They're from Taiwan and China and Korea. And we've got others. Leo asked a question. He's here in Bloomington, but he's from Colombia, South America. So we have a very international group tonight. So Lily Jean, I think you're out there in like Guam or something. Is that right, Lily Jean? Somewhere in the South Pacific, right?
Yeah, just north of Guam.
Yeah. And what island are you?
Saipan.
And you're not in Bloomington then. You're coming all that way. So you're like, so we'll give you second question. Amelia, go ahead, ask your question.
Thank you for being our guest tonight. It was very interesting. I guess you've answered my question, but how low do you think you can go with this? And I appreciate that you said it's a non-literary application, because in Japan we love to use it, but if it has to do with language or words or something, it presents some barriers. So how low do you hope to go with these?
Kodu did studies where I think they went to second grade, and so I was thinking second grade would probably be the lowest we would go. Although Pele has a preschool in his house, and he might have other ideas.
Yeah, I've tested it on preschoolers. I haven't tested the robots yet, but the robots are toys, and the kids treat the coding as a toy activity, and that's the big deal. So we need to test it. I hope we can go to the upper end of preschool.
Yeah, that's fascinating. Thank you.
The thing they tend to build, and again, this is a one classroom running, so that's what we've seen. they tend to build remote controllers because that's the toys that kids like.
Oh.
They recode a remote controller. We actually explicitly delete the whole code every time. And every week they come back and they recode it.
They're
And
creating the same program over and over again. So the learning objective there for from the CS concept is basic reactive programming, but they key onto that right away. But there's no, the state is all managed by us. So it's not, you know, what you would think of it's sort of like the Hello World program, except you do get the potential for feedback, but generally they don't use that, right, Pelly? They just do microbit event goes to robot action generally.
yes, yeah. And you know, this is an after school, so I'm not really directing the class. I give them the hardware,
right,
and they just do whatever they want for an hour, and I'm just kind of observing what gets them excited. But they do have to reprogram everything from scratch every time. Yeah, it's the hope is that we can go actually pretty low, but we haven't so far. We've done fourth grade, but we're gonna try going lower. And yeah, I have 8 preschoolers in my basement.
Amelia, my son's third grade class did a lot of work with microbits last year.
Oh, okay.
And so that was really nice to see. But I'd had him in the house since he was about 4, I think, is the first time we started utilizing them. So
okay.
Yeah.
So a couple time zones closer than Japan, we have Sapan. Lily Jean, would you like to ask a question?
Yeah, I don't really have a question that hasn't already been answered by others that asked in the chat or in conversation, but I did just want to make a comment that I really enjoyed the presentation. It's something new. I've never heard of it before, but looking at like the pictures and what you guys were sharing, it reminded me a lot about another app that I used for my master's that looks pretty similar. And I had to search back like to what
Okay.
that program was called, but it was the MIT App Inventor.
Oh,
That's
yes,
the one that
yes.
I used
We're very familiar.
with the
Yeah.
block. Yeah.
Yeah.
But
App
that's the one
Inventor
that I
is
had
used-
experience with.
That's right. App Inventor is used for programming smartphone apps. And
Yeah.
the closest that we had to that, and we chatted with them quite a bit during the Touch Develop days, because we had essentially a programming environment, web-based plus phone-based for programming the phone. Yeah, App Inventor they have a whole set of blocks for graphical user interface for, you know, some of those programs get very large, some of the block programs. Yeah.
Yeah, it can get pretty extensive, but I really appreciate Amelia asking that question about like the lower grade levels, because I'm at the elementary level and I really liked the App Inventor, but then thinking about like using that with elementary kids doesn't really match up. So I think this would be a lot more suitable for the age group that I work with. So thank you
Okay.
for sharing.
There's one thing I would like to add, and this is something I noticed both from also volunteering in today's school. The fact that you're not on the internet is actually so refreshing, because it's really hard to keep focus of students when they have access to every possible random stuff that's going on the web, and
Yeah.
there's no way you can block a browser. The kids will find a way to get to what they want, and I don't have to worry about that. There is no internet.
Yeah.
It's a
Thank you,
feature,
Luigi.
not a bug.
Before we go to another question, I mentioned that we had Microsoft people on a show on my Silver Lining for Learning podcast show a couple of years ago, and I'll just mention it was from Microsoft Philanthropies
Oh, yes.
Teals program.
Oh, yeah, the
We
Teals
had
program. Yeah, we know them.
Kevin Wang was on it. He has helped 1,000 high schools across the U.S. build successful, sustainable, and diverse CS programs with 700 companies and 0.2 million hours of work. It's a huge project. So you know about Teals then?
Yeah, Teals is actually Kevin Wang started that, and he's moved on. He has a nonprofit called Mentors in Tech now, but the Teals program still goes strong, and it's actually gone internationally. Teals started, and Pelly was a Teals teacher, but basically with APCS, it's branched out. But the idea was you have teachers who don't know the CS, but you have tech people who know the CS, and the pair of them can teach, and you can have knowledge transfer. Pelly can talk to that more if people are interested. But yeah, TEALS has gone internationally now. It's in Africa, it's in Europe, it's in, I think, South America. Yep.
I'll put the link into the show in the chat if anyone wants to watch it. Bo, please save all the links that have been mentioned tonight. We want to share with the students who aren't here. We're recording this and we'll send them the links. Who wants to ask the next question?
Yeah, please.
I imagine Jill does, because this is her area. Jill from Taiwan. Jill, you want to jump in here? She's here in Bloomington resident. She just finished her PhD and flew to Indiana to spend a year on a Fulbright. So Jill?
Fantastic.
I'm not expert of coding. I'm learning it, but in my educational setting, I mean, in high school, I actually teach students how to use the coding to control the virtual object in the virtual reality settings. And also, my son is learning. It's a cat, scratch cat. Yeah, it's also a coding program. So my question is like, do you recommend or suggest learners who has their first time in learning coding to learn this kind of complex stuff by themselves? Or do you think a teacher is necessary for them?
Oh, I see.
Yeah.
So can you make it self-directed? Is that the question? So, or do you need a teacher?
I don't think I will use the self-direct learning, because in self-direct learning, probably they still have videos as a virtual expert. But in my classroom settings, I try to lead my students to probably learn this kind of stuff by communicating and negotiating with each other.
Yes, I think that's very
Do you think it's a good way?
Yeah, we see a lot of that going on. So in the class that I teach on Sunday mornings, believe it or not, we have very like week to week we have guests. We have some kids who don't know the environment, and that, you know, I just have the kids who know it teach the kids who don't know it, and it's super. Like they just get together, you know. So definitely like some kids latch onto it super quick and are self-starters. I think if you've had any experience playing a game with a D-pad, you already know how to navigate the cursor. And once you get the idea of the do when, which is a very simple idea, now left side is an event. When this thing happens, do this action, they're off to town. And you know, there's a lot of complexities underlying it, but the GUI and the programming model hide a lot of the complexity of the event loop and all that stuff. So yeah, I think that's a key aspect. Pelly can talk more maybe to the experience with the robots, but I do think that's really, in my mind, key, that the kids learn by exploring, sort of a constructivist way, and then they teach each other. And then, you know, some of the concepts are a little like the radio group. We definitely have to tell them, like,
Yeah.
you have to do this special command. Like that one's a weird thing, because it's like, it's almost like, okay, this thing is talking on this channel and you have to talk on that channel. But then some of the kids like figure out, oh, so I can talk on someone else's channel. I mean, but there are some things we have to, Pelly, you go ahead. You
Yeah, I think, you know, you have to bootstrap things like the radio, but then it's just like a toy for them and a game, and they are used to teach each other how to play. And that happens naturally in the classroom, that they're going to show each other, you know, it's like, how did you move the robot? How you change the color? And someone will go and help them, because the robotic stuff is usually a group, you know, they'll be in group of 2 or 3s.
Thank you.
I think you
And
see
you-
the dynamic of them treating this as a toy and as a game where they will teach each other how to beat the gamers. Yeah.
Okay, so thank you, because your words, both of you, just tell me I'm on the right track. Yeah, because I just lead my student, because I don't think this kind of teaching is linear. Instead, they are probably spiral shift of instruction. So I just want my students or my kid to learn this kind of stuff by themselves at first, and then they can ask their peers, so that, or even the teachers, or even to look for any online materials for themselves. Thank you. Yeah.
Yeah, I mean, the level of teaching we've done was showing them once how to make the robot go straight, how to turn, how to stop, how to set up the radio. The rest, they combine the concepts together. The fact that they could use the buttons to create different commands, but that was a one-time shot when we explained that, and then week after week they came back and redid it. Yeah.
So self-directed learning is the big thing right now, STL, and it's been my research the past decade. For my students' purpose, after spring break, I'll go through 7 of my studies on STL. Emmanuel and Esther were the ones that always I tend to cut off at the end. I want to give you an opportunity. I don't know if Tom could stay for 2 more questions.
Sure, of
or
course.
2 or 3 more questions, but Emmanuel and Esther, I know oftentimes you get cut off at the end, but I want to give you a chance here. Either one of you. Yeah, Esther.
I enjoyed the talk because we did a course in making, and we used a lot of Scratch and Microbit to come up with our with games that we can use in our classrooms for students to understand some concepts. I didn't quite master it a lot because I was taking it together with other courses, but I think I liked it, and I intended to venture more after I finished my coursework. So I've really enjoyed the talk.
Thank you.
It wasn't so new to me. I was very excited because this is something that I have encountered and interacted with before. I just think it takes a lot of time. You have to understand it, especially Scratch.
Are there
coding
levels of
Yeah, I
understanding, like phases that teachers go through in understanding and integrating this?
Yeah, I mean, I think the teacher PD and sort of, I mean, that's complete unknown for me with microcode. Like, and that's something we'd love to explore, is sort of bringing microcode to places where the teachers are just like maybe they have no tech background, or they're afraid of tech, or self-identified as like non-techie, and just see if we can bring them up on microcode pretty easily. And then maybe have a path to get to Makecode, which is a more sophisticated programming experience. But that's a whole nother question. There's lots of things we'd love help with, by the way. Everything is open here. Everything is commercially available. So the shields, the microbits are commercially available. And of course, everything's open source, and we're a research lab. So we'd love to see people building on this if they want to do evaluation or contribute to the platform, the source code. We're quite open. Microsoft Research, I didn't sell you on Microsoft Research, but we look for opportunities to partner with academia. We've had a great partnership with Lancaster University around the microbit, and we're open to all possibilities.
So Bo got another dissertation idea this week. Seems like every week, Bo's probably thinking about, oh, I can take this, because you've been coding in this area, Bo, for a while.
I'm going to have all the dissertations by the time I'm done.
So we have EDD students who have to do more practical types of dissertations that might in fact impact their home base where they're working, and that's why I said Bo's one of our EDD students. But this is definitely for PhD students as well, could jump in with many questions that they might ask. Emmanuel, did you have a comment or a question? You're muted.
Yeah, I actually enjoyed the talk, but I don't have anything. I was actually following everything. So.
Okay, great.
Yeah.
Anyone, 1 or 2 more last questions? Who would like to ask one of the last questions?
I had wanted to ask about special needs. During that class that I took, it looked like this was more applicable for regular normal kids. I don't know if anything is being done for
Well, yeah, I put that. We haven't done anything particular. We just have some experience with neurodiverse kids in our classes. So I mean, this is just ad hoc information, so nothing formal. I mean, we've just seen, that. I mean, I've observed some kids who are just like, generally in my class, very withdrawn, or they're just not communicating with the others, but they're totally lighting up with microcode. I can't generalize from that. So we haven't done anything particular there other than to use the maybe to luck into using the game controller. So some kids really just love to both. They may not be have the social emotional intelligence yet, but boy, they can use a game controller. So
We
there's
have a student yeah. There's at least one student in the class who has motor skill and probably some mental disability, and he's has got a big smile on his face. He's making that robot go everywhere randomly. And he literally had maybe a minute of instructions because he was, I'm going to figure it myself. I think the physical controller, we could do something better with the joystick.
Yeah.
But he was able to actually use it on his own.
I think this is something where we are not experts, and we would love somebody who wanted to do an evaluation to partner with us, or to take the technology and just go off and do the study themselves. In terms of other things we could do on the technology side, we have talked about like having like with JackDeck, we could actually have a screen reader. We could tell you where you are as you move the cursor around. Now, we still have the issue with the microbit that the display isn't readable by somebody who has vision impairment. But maybe with the robot, you can move the robot and feel the robot move. So again, I think we have this extensibility in the platform where we could, for example, do text to speech on the cursor. So that's a whole another aspect, again, unexplored, but there's potential there.
Another dissertation, guys. Any final comment from anyone that didn't get a chance to make a comment tonight?
I can make a comment. So first, congratulations, Tom Ball and your team on your incredible achievements. It's amazing. And as a teacher, I really like the saying on your last slide. You said that the core goals for the microbit and its ecosystem to be the most effective tool at teaching digital skills and creativity. I do think that those two words are very important in our school education. No matter it's K-12 education or university education, our students need those skills. And so I really like this lecture. Thank you.
Oh, good. Thank you. I can't take credit for that. I'm putting it in the chat. That is the text from the Microbit Educational Foundation. But we very much agree with that. I mean, the thing that I'm really interested about myself personally is with microcode. It's like when we say diverse, that could mean so many things. We could talk about underrepresented populations. We could talk about people who don't have access, the digital divide. And so I've been thinking really about, how could we take microbit programming and physical computing, that experience, to remote places that don't have the resources. Well, remote places are places that don't have the resources to invest, in the computers. That for me, I would love to again partner with somebody. I am working with some nonprofits who are, who have those contacts, and
I really like this word, remote places, and also disadvantaged regions.
Yes.
And they also need these skills. Thank you.
Thank you. Thank you very much.
Thank you, everyone, for coming tonight. And I have Tom's email. If you have questions, you can send them to me. I'll forward it to Tom. If Richard and Kelly want to share their emails in the chat window, we could write them down. Thank you, Richard, for jumping in here tonight and joining us. It's great to have three. I promised one person from Microsoft. We had 3 people from Microsoft in one event. So can I get everyone just a smile, wave their hands? I'll get a snapshot with everyone who's here. 1, 2, 3. Thank you, everyone. Thanks for coming tonight. Rojin, you want to make a final comment before I close the session? Because you organized it all.
Yes, thank you.
You're welcome. I mean, I really enjoyed the talk. I'm also working with Tom, like Tom and Pelly collaborating on a project. So I'm just looking forward to it. If you have any question, perhaps maybe you forward it to Tom, and then I'll discuss it with Tom.
Yeah, absolutely. I'm happy to continue the conversation.
Sounds good.
Thank you so much, everybody. And we'll take a break. My class will come back and talk about the articles for next week. So those people who are in my class can come back briefly. We won't be going for too long. So again, thank you, Tom, and thank you, Richard and Kelly.
Thank you all.
Bye-bye.
Thanks to everybody. Great to see everybody.
Thank you. Thank you.
Bye.
I'm stopping the recording. Week 8, part 1. And I will stop it. R678.